rotations. Okay, so our next transformation here. So a rotation is a transformation that moves every point of the pre-image. Okay, so your starting image, again, is called the pre-image, through a specified angle and direction about a fixed point called the center of rotation. Okay, so you have a center point that all of your points in your pre-image are going to rotate around. Okay? So if the point being rotated is the center of rotation, then the image and the pre-image are the same point. Okay, so if your point is on that center of rotation, it's just going to remain the same. Okay, just like if we had a reflection and it was on that line of reflection, that point stayed the same. Didn't move around. Okay, if the point being rotated is not the center of rotation, then the image and the pre-image are the same distance. So the same distance from the center of rotation, and the measure of the angle of rotation formed by the pre-image, center of rotation, and image points is x. So if I have this triangle shape, okay, and I have a center of rotation here. Okay, this is the center of rotation. Okay, I'm just going to label this top point A. And I want to rotate that image around that center of rotation. Okay, so if I extend this to that center point, and I want to rotate it 90 degrees. Okay, point A would be here, and that would be A prime. Okay, and your rotation would be this way. I know that's not drawn to scale or the same, but hopefully you're kind of getting what I'm saying here. So that rotation angle there would be x, and in this case I rotated that point 90 degrees. Okay, so this is kind of what your rotation looks like. It's moving around that point, and it's the same distance from that point. Okay, so we are going to be drawing rotations in the coordinate plane. So just like we were before with reflections and translations. Okay, so the following rules can be used to rotate a point either 90 degrees, 180 degrees, or 270 degrees. And this is counterclockwise. Okay, so these rules are for counterclockwise rotations. Okay, and they are about the origin. Okay, origin point is 0, 0. So that's going to be the center of your rotation, and every point is going to rotate counterclockwise. So to rotate 90 degrees, you're going to multiply the y-coordinate by -1, and then interchange x and y coordinates. Interchange meaning switch their sides. So if your original point is x comma y, what this is saying is how you're going to change for a 90-degree rotation. You're now going to have opposite of y comma x as your new coordinate point. So you're multiplying y by -1 and then flip-flopping those two values. For a 180-degree rotation, you're going to multiply the x and y coordinates by -1, and you're going to keep them in their same positions. So you're just going to take the opposite of x and the opposite of y. For 270 degrees, you're going to multiply the x coordinate by -1 and then interchange the x and y coordinates. So in this one, again, you're switching the two, and your x coordinate is multiplied by -1. So your new coordinate here would be y, comma, opposite of x. Okay, so make sure you do have these written down, because you will need to change this original coordinate in order to rotate those degrees. Okay, questions on that before I go through an example? Okay, these are what you need right here. These are important. So, going through example 1, we have a parallelogram WXYZ with the following vertices. We want to graph that parallelogram using those points and its image after a rotation of 270 degrees about the origin. Okay, so first thing we want to do is graph that original parallelogram. Okay, so we'll plot each of these 4 points. So we have W is at -2, 4. Make sure you label those. X is at 3, 6. Y is at 5, 2. And Z is at 0, 0. Okay, and then I can connect each of those points. Okay, so here's my original. So that's my pre-image. So now what we want to do is rotate it 270 degrees about the origin. So again, this is rotating it counterclockwise. So since we're rotating 270 degrees, we're going to change each of our coordinates according to this rule right here. Okay, so again, we're multiplying the x coordinate by -1 and then interchanging x and y. So again, here's your rule, and here's what we're moving them to. So point W is done for you. So the original coordinate for W is -2, 4. So what you want to do first is multiply your x coordinate by -1. So if I multiply my x coordinate by -1, I'd end up with 2, 4. Right? Then my second step would be to interchange those two values, and that's how we're getting W prime to be 4, 2. Okay, we're going to do the same thing here for point X. First, we're going to multiply our x coordinate by -1. So that becomes -3, 6. And then we want to interchange those two coordinates, the x and y, to get our x prime coordinate of 6, -3. Okay, moving on to point Y. Again, first, multiply the x by -1. So we'll take 5 times -1. So we have -5, 2. Then we need to interchange x and y. So we need to switch their values to get y prime of 2, -5. Last one is 0, 0. If I multiply 0 by -1, what happens? It stays 0. And then if I interchange the two, it just stays 0, 0. Okay, so it does stay 0, 0 because that is your center of rotation. So if you ever have a point 0, 0 or the origin, that's the center of your rotation. It should stay the same. So now I can go through and plot each of these prime coordinates. Okay, so we have W prime at 4, 2. That's about here. And label that W prime. We have X prime at 6, -3. Label that X prime. y prime is at 2, negative 5. And z prime is still at 0, 0. So again, I can go through and connect each of those points. Okay, and here would be my image after that rotation. Okay, so again, it's rotating 270 degrees, and it's rotating around this way. Okay, it's rotating counterclockwise. Okay, so this would also be a rotation clockwise of 90 degrees, but you don't have to worry about that. Okay, so since it's counterclockwise 270 degrees, it's clockwise 90. Okay? Questions on this first example before we do a few more here? Alright, so on the back, again we want to graph each figure so with the given coordinates, and then its image after the specified rotation about the origin. Okay, so we're still rotating about the origin. This first one is a trapezoid. Okay, it has vertices at F, G, H, and I. So you want to first plot each of those to create your pre-image. Then we want to rotate it 90 degrees about the origin. So how we're changing that XY coordinate will be opposite of Y, comma, X. Okay, so first plotting these 4 points. Point F is at 7, 7. Okay, I'll plot that point and label it. Point G is at 9, 2. H is at 3, 2. And I is at 5, 7. Okay, and I can connect each of those points to create that trapezoid. Okay, now what I want to do is find each of those prime coordinates. Okay, so to find F prime, first thing you're going to do is multiply your y value by -1. Okay, so my y value I'm looking up over here is 7. I'll have 7, -7. And then I want to interchange the two. So my F prime coordinate will be -7, 7. For G prime, first thing I want to do is multiply y by -1. So your 2 value becomes -2. And then I want to interchange the two. So flip these. So I have -2, 9. For H prime, again, multiply your y coordinate by -1. So we have 3, -2. And then interchange the two. So we have -2, 3. The last one is point I, multiplying y by -1. So we have 5, -7. And then switching those two values. So I prime will be -7, 5. Okay, from here, I can plot each of those prime points. So F prime is at -7, 7. So plot that point, label it F prime. G prime is at -2, 9. H prime, -2, 3. And I prime is -7, 5. Okay, so here would be my image after a rotation of 90 degrees counterclockwise. Okay, questions on number 1 on the back there? All right, then I want you guys to do number 2. Okay, plot those points, change the coordinate correctly, and then plot those prime coordinates to see that rotation. All right, so here's number 2 on the note sheet. So you're rotating 90 degrees counterclockwise. I have my prime coordinates there. L prime is at 1, -1. M prime is at 4, 0. And N prime is at 2, -6. Okay. I do want to go through number 3, so that's a 180 degree rotation. Okay, so we have triangle ABC with the following vertices under a 180 degree rotation about the origin. So we're taking opposite of X, opposite of Y. So plotting these original points here, we have -3, 5. Point A, 0, 2, point B, and -5, 1. Okay, so here's that triangle. Now changing our original coordinates, we just have to take the opposite sign for our prime coordinates. So A prime will be at 3, -5. B prime will be at 0, -2. And C prime will be at 5, -1. Okay, so you're just taking that opposite sign for each of those. Okay, so from here I can plot those points. So we're at 3, -5. B is at 0, -2. C prime is at 5, -1. Okay, and that'll be my image created by that rotation. Okay, questions on how to graph these rotations, how to change your coordinate points, anything like that. All right, so at the bottom here, I do have this kind of review. So for 5, 6, 7, and 8, we want to name the transformation that will map tree A, so this tree right here, onto the indicated tree. Okay, so tree A is our pre-image. How do I get to tree B? Is it a translation, a rotation, or a reflection? It could be a translation or a reflection. Okay, so I could reflect over this line here, or I could slide this point to here. What about tree A to tree C? That's a reflection. Okay, tree A to tree D. It is a rotation. And then A to E. Translation. Or slide. Okay, if you would have said reflection, I would have gave you that too, because your reflection line could have been through the middle of tree B. Okay, questions on those, just naming what type of transformation it is? All right, the last part here is about reflections, okay? So you're given a coordinate point and you're asked to reflect it over a certain line. So the graph there is just to help you if you need it. Okay, I know I have problems like this on your quiz and your test that you'll have at the end. Okay, you'll just have a coordinate point and be asked to reflect it over a line. You don't need to plot it on the graph if you don't have to. Okay, the graph is just there to help you. So point M is at 4, 2, and we want to reflect it over the x-axis. If you remember how to change your coordinate, you can. Otherwise, plot it on your graph. So it's at 1, 2, 3, 4, 2. Okay, that's point M. And we want to reflect it over the x-axis, which is right here. So that's 2 away. So count 2 down will be M prime. So what I did was just change that y value to the opposite sign. Okay? When you get problems like this, you do need to rewrite out that coordinate. So my new coordinate M prime is at 4, -2. Okay, same thing for 10. Point N is at 5, 1. This time we want to reflect over the y-axis. Now if you need to use the graph, you can. Otherwise, your rule says change your x value to the opposite sign. Okay, so my new coordinate will be at -5, 1. And again, you can use the graph if you need to see that reflection. For 11, we want the y equals x line. Okay, that line is that diagonal line through the origin with a slope of 1. The rule for that one is to switch your x and y values. Okay, so my new coordinate point will be at -2, 3 after that reflection. Okay, questions on that part?